minus MA is equal to 0. Isn't that the same F is equal to MA? Isn't that? It's a different interpretation, just playing with it FED. But it makes your life very easier, and I'll show you why. Now here, in this problem, this is the actual load you have. Let's first draw the actual load with blue. You're gonna get the pressure is this way, right? PB, AB. That's the pressure force. You're gonna get another pressure here. PA, A at A. And then you get another pressure here. P, C, AC. And these are not equal to atmospheric pressure. Why? Because it's inside the pipe. If it was exposed to the atmosphere, you get P0, the atmospheric pressure. So in general, you have pressure here. And you see this pressure, in fact, is the distributed load. That's the pressure for this capacitor. Why you replace it with one load? Yeah. So these are pressure. What else do I have? The real load. So blue is real. Blues are real load. Real forces. What other real forces do I have on the FED? You remember we walked over the
Normal forces.
huh?
Normal forces.
The normal force. What else?
Reaction.
Reaction. I mean, in general, here, if you assume it's a pin, you have dx dy, right? If it's a pin. If this is welded here, how many unknowns you have? Say that? 3. dx, dy, and d. Well, let's say just a pin approximation. So those are real loads. Now, inertial loads. I need to use a different color. Green. Greens are inertial load. Green are inertial forces. So inertial loads come from the places that the fluid is either coming or leaving. Well, you remember we did this integral, rho v dot n, yes. They show that v dot n is 0 when you don't have inlet, like solid boundary. Why? Because the velocity, either the velocity is 0, the viscous approximation, or v dot n is 0. In VC, the velocity is normal to n. Right, so this 0, so this term appears only here, here, and here. You see, the outlets and the inlets. Everywhere else is 0. So here, what do I have the initial load? Look, V is going this way. So what's V dot N? Can you tell me, is it positive or negative? It's positive. Why? Because look, N is here, B is here, right? Both vectors have the same direction, no matter they're going to left or right or up or down or angle, because they have the same direction. The angle between two vectors is 0, so the cosine 0 is 0. So V dot N is the positive times the V. V is negative, so the total thing V times V dot N is this way. Right? When you put it on FED, what should you do? Switch the sign. So when you put it on FED, this is the actual sign of inertial load. So VC times M dot at C. Right? That's exactly, it's not, I know a lot of you guys are just smiling and say, hey, he's repeating himself, he's repeating himself. But some of you guys, they have no idea. So that's the reason I have to repeat it, to make sure everybody in the class knows that. Right? So this thing is just the same thing, except you just evaluate this integral. So this integral becomes rho A, VA, right? Times rho, this group is M dot. So the end result is M dot times V. We see that when you evaluate this integral. So M dot times C at C times VC, and it's going this way. But when I put it on my FED, I put it this way. So that's VC M dot C. Let me erase the extra space here. That's it. I don't need to do integral. That's the advantage of you, is you're done. So what about here? You see, V dot N is what? V is going,
V dot N is gonna be positive.
yes. Let me bring this back. I don't know why this turns off. Information don't need to change. So as you can see, the velocity is going to the right, 2 meters per second. So V is this way. So what about V dot N?
Same direction.
Yeah, so V dot N is positive because N is going this way. And V dot N positive, time positive, so the N, entire thing is positive. So when you put on a video, how do you put it? The opposite. So that's going to be what you write here, M dot
BB.
D times dV. Just like that. What about here? V is going this way, right? What about V dot N?
It's gonna be negative.
So V dot N is a negative, right? Times this is going to be, so V dot N, this is your V going this way. So V dot N, N is this way. That's VA. So V dot N is negative times VA, which is negative, so it's positive. The actual thing is positive. But when you put it on FDD, you put it this way. It's called M dot A, VA. Because the end result, you see, you have one negative this way times V dot N, which is negative. Right? Negative times negative, positive is actual. When you put it in FDD, it goes down. M dot A, VA. Now, what's that? This is the answer to quiz, which has real loads, the balloons, and inertial. What's the advantage of doing that? The advantage is once you have this FDD, you do not need to do any kind of integral, any equation. You remember I said every time you start with the triple integral, simplify it for that. That's extra work. Now you're back to vector statics. Now if somebody asks you find dy, find dx. If somebody asks you find dx, what do you do?
Sum of the forces in the x direction is
That's
zero.
zero. It's zero. It's not no longer MA, it's no longer the surface integral. It's just vector statics, sum of forces, so you write this equation. Sum force in x0, sum force in y0, sum moment at any point, 0. Right? What is that equation? The moment equation. It's a null equation. Look, all of these are passing through the same point. And vector static, if you study vector, I see again, I see some of the students are just easy, but some of the students are very confused. If you study vector statics very well, you know that this equation is null. Why? Because they're all passing through one point. The some moment over that, 0 is equal to 0, null equation. So only equation that give you result is these two. So let's do that. Starting with this. What do you get? So this is one force. So I get positive VC and M dot C. Then I go to this blue. These are forces. Now we treat everything, even the inertial, the virtual forces, as a real force. So M dot CVC plus PC AC, right? So all the forces here. And then plus dx. Should I add dy?
Nope,
Why?
because it's going in the right direction.
It's in the y direction. I'm doing some force in x. Right? Make sure you don't make the mistakes like that in the midterm, because I may do something similar to that, and then I'll be reading your answer. If I see a dy here, then I'll probably not grade the rest of it. It's a big fatal mistake. It's just, I call this fatal mistake. They're conceptual mistake. Plus dx, nothing from dy, and then I'm going to leave something that you should tell me. Plus, minus, PB, AB, and something is missing. Is equal to 0. What is missing here?
The MBVB?
Yeah, say that?
The M dot B VB?
M dot B times VB, that's right. Positive or negative?
It would be negative.
That's right. Do I get any contribution from these guys, these two?
No.
No, it's, they're in the y direction. Guys, isn't that exactly vector statics? Because you have all the force on FED, right? You don't need to think about like surface integral, volume integral. But look, what if I had a parabolic profile, not constant? Well, again, you can do this, which you will, but the m dot here, you need to integrate u dy rho over this to get m dot. To get the net point result on m dot. Again, it's just consistent. So this is a very general thing to do this. In fact, everybody, they do that. Engineers, they do that.
Professor?
Yes.
Now, we do the VC MC or the VB, the M dot B VB. Do we not include the normal velocity for like
It's
if
in
we're
the-
looking at all the forces here? I
It
see
is-
like we have the dash line for it.
It's right here.
Okay.
So m dot c is what? Can you tell me what's m dot c?
Okay, so M dot C is M dot C VC then, or
No,
it's
no,
the
what's
It's,
m dot c itself?
VC times.
Who is
your
weighing there?
normal.
Say that? Who is saying that?
VC times your normal.
No, no.
Well, it's a rho A V.
Rho,
Rho
Area
V
times
squared
velocity.
AC.
Square.
Rho V D, or
no, no,
rho dA.
no. Rho VA. What rho VA? What kind of rho VA? At what point?
That's C.
At C.
Rho C, VC, AC. So this by itself has V in it.
okay. So we're doing the M dot. Okay, I got
So
it.
always this question that he's asking is because he is understanding it. I know some of you people, they understand it, but you don't want to ask question or contribute to class, which is fine. I've discovered a lot of good students we have here, which they totally understand it, but they don't want to contribute, which is totally fine. But it doesn't matter how you do it. You contribute or not, you come to class or not. When I give you a midterm, I expect you to be able to at least do these things that I do. And be able to understand. Now, let's go to y equation. So for y equation, what do you get? Let's just start up on as. I want to do sum in y0. I start with this screen force. Should I include it?
No.
No. Should I include the proof right here in the y direction? No. What about dx? No. What about dy? Positive dy or negative dy?
Positive.
Positive dy. You go to, this is not in the y, not in the y. Now what do I have in the y? What do I get from that?
Negative
Negative.
EAA.
And then, am I done?
No.
I have one force which is inertial
Negative.
force, it's not real force, it's just imaginary force, but it exists. What is that?
Negative.
M dot
VA. Positive or negative?
Negative.
What else?
equals 0.
That's it. Is it equal to 0? That's it. Now, if you can do that, the rest is just a piece of cake. For example, somebody may give you numbers here. In the midterm, in fact, I'm going to do that. I'm going to say this one is fixed, just like that. The step one, draw the FED, which is that, including inertial loads. Step two, find, for example, the y component of reaction force with regard to hold this in place. In that case, you really don't need to waste your time with the first equation. You write this equation, and then substitute the number. What number do you substitute? For m dot, where is that? M dot A. What do you substitute for m dot A?
Rho
Rho
A.
VA. So you come here, the V is not given. So what? Where is that? A. Well, V is given. So V, and then how do you find rho? Well, the density is same in compressible, rho V A. The cross section also given. I'll put the cross section for you. So you have m dot A. You substitute the number here. You have VA. And then the pressure at A, let's say I give you pressure here. and don't give you pressure 8. Then what do? You just put unknown pressure 8. You can, which you get good partial, very good partial, but you don't get about 100 out of 100 for that question. If you want to get 100 out of 100, what do you do?
For the
So I don't give pressure here, I give pressure here. Bernoulli equation. You write the Bernoulli between the streamline. And if the areas are same, I may give different areas. If the areas are same, I'm sorry, velocities, and this height is small, I mean, if this height is like 10 meters, then you have to put it there. Then you find pressure at A. In some cases, it may be equal to pressure at C. You see that? So it may not be a very straight, but it's not too hard. It's just the same thing you studied so far. A combination of continuity, Bernoulli, and momentum. We haven't studied energy. So after we study energy, we just give you a problem that you can combine these to find a numerical values. So then you put it here, PA, there you go. You have area, you find dy. That's it, one line. So the second problem. I'm going to give this question to you, but I will change this question from the continuity section, mass conservation. I'm going to change the question and say, well, I fix this to the ground, just like I did for that. So I put it here. I put a link, I put a pin, I fix it ground. Again, draw FTD. Alright, step one, draw FTD part A. Part two, solve it. Find the reaction in the X. So when you draw FTD for that, what do you get? Just like that. You get actual loads here in X and Y, Fx and Y. Right? But is that all? Let's say this part is exposed to the atmosphere, but this part obviously is inside the pipe. Right? So here you have pressure, target A, PA, AA. Let's say this point A, point B. What's my PB? AB, what's the value of PB? Let me ask, you must say, what's the value of PB here?
What's the correction?
No, what's the value? What's the magnitude of PB?
Of the magnitude? 1.5.
No. So think about it. What's the pressure here? You see here is PA, AA. What's the pressure here? Say that, you say
Zero.
it's zero. Why?
Because it's exposed to
That's right. Because it's exposed to the atmosphere, so it's gauge force is zero, so you only have a pressure here. What else do I have? So these are real force. I'm done with the real force. Now, in the vector static, when we move over the border of the boundary, you would include every force, no matter real, imaginary, inertial. So these are real force. What about inertial load? You put how many inertial loads do I have on this FTD?
2.
2. One inlet, one outlet. There is no inertial loads here. The fluid is not exceeding. Right? So inertial, the normal is this way. This is the normal. The velocity is this way. Right? So yeah. So you say velocity v dot n is negative times velocity, which is positive, is negative, so the actual thing is here. When you put on a FTD, it's going to be opposite of that. So that's m dot A dA. All right, what about here?
It'll be,
Yeah, you really need to think about it. You see, when I ask you, I don't expect you to immediately say that. You have to do some bookkeeping. Say, well, the normal is this way, velocity is this way, n dot b dot vb is positive, right? Times m dot is positive, so the actual thing is going this way. So when you put on FTD, you have to split the sign. So that's m dot b vb. Now, if you want to find the reaction at x duration, what do you do? Vector static, sum of force in x0. What do you get? PA, AA positive, minus m dot BBB plus m dot ABA is equal to 0. No integral, no, but you really need to understand that integral, how we get this equation out of that triple integral. And we will have a question for that, the conceptual question. Next problem. Now, in this problem, this one thing I may do, again, I'm not gonna give you all these values, BB, BA, PA, PB. Again, I may give one of them, right? I may give pressure here, not pressure. I may give velocity here and the pressure drop, delta P. But what I ask is find the actual magnitude of this effects in newtons. Then the question is, what do you do for velocity at B? I only give delta P and velocity at A. What do you do there? Can I ask a question? How do you find velocity at B? If you only have velocity at A and delta P.
Bernoulli.
Who said that? I mean, I can see who is ready, who is not. This is one good choice. This course, I know you have weekend plans, you know, that you have to cancel all of it. Because you see, when it comes to grading, I'm very brutal. I will drop, if it's 70% of class, I'll drop to 70 F. 70% F. I'm not gonna say, hey, you know, no, so far everything is good. So far we only have a few F's, but a lot of A's. But I'm not gonna say, well, 70% is F. Let's put it on careful. I'm not gonna do that. You need to put effort on this. You won't graduate until you understand these things. And we still have time. The good thing is we still have time. But you need to cancel the plans. You need to cancel your plans. All right. Next question. Again, you have something like that. One of these problems, yes.
So when do you know when you need to solve a problem using this method versus using all the equations?
They are going to be exactly the same. It's your choice. You remember when we did vector statics, you had cross product using determinant, IJK, you put in a determinant, you applied mass, and you realize it's 3 hours you're working on one single determinant, or 2. Not even one problem, you're not done with one problem. And you realize that friends who know how to do the method of movement, the manual method to move the components, you remember we did that? They already do like 6 problems. And then you realize, well, you know what? Let's stop doing the time-consuming method and do the fast method, right? But the end result was what? Exactly the same. We had homeworks. Do it using determinant, do it using fast method, and verify they're exactly the same. This is exactly the same. This is the fast method. You put the always on a video. You just write vector static equation and you're done. But if you want to do integral, which I recommend initially do integral, just to understand it. The way we did in vector static with the determinants, you have to understand what the determinant is before you do the fast method. Right? Then, but at some point you decide, I'm not going to do the integral anymore because I know how it works. Right? Well, for midterm, be ready for all of this. Yeah.
So if you run into a situation where you're missing variables, you can use the other two, or the Bernoulli's equation?
Yes.
Most likely to find.
Most likely, yeah. And the other one was Bernoulli, the other one was
Continuity?
continuity. You see, it's ready. I can see a lot of people are ready here, but there are some people who are not ready. And they, for some reason, they don't want to be ready. The assumption is he's gonna pass us, he's gonna pass. I'm not gonna do that for this course. I'll be very, very brute with this course. I'm not gonna pass. If you know it, you'll pass perfectly, flying colors. But if you don't know it, you will not pass this course. I guarantee. And next semester, again the same thing. I'm actually talking with Shrey and Dr. Ranjan that we want to improve the quality. We don't let you pass if you don't know this. It's a very, very important thing. Fluid mechanics is used for in FE exams, in all the other things. you really need to understand. These are basic, these are not hard problems. These are the problems in the book. You see that this is the problem in the book. If you can't solve this, you officially you're not able to pass the school. All right, so again we have a bend pipe here, and this he asked you, well, draw the FPD for that, and he gives all the velocity. Well, I may play with this. I may just put this velocity here and erase that and change the cross-section area. Right, shrink this pipe a little bit down, increase this pipe, extended the cross-section. So you have different numbers, different, but as long as you understand the basic concept, like you don't really have any problem at all. Right? Again, for this, I might say draw a FED. So draw a FED, so you have PC, right? AC, this way. What? Here's, let's say, atmosphere. What do I have at PV?
Atmosphere,
Zero. Don't get it. So you don't put PV AB because it's zero. And you have PV. Then what about this? This inside pipes. What do you have? PA, AA. Alright? Now, what else do you have? Well, here you don't have reactions, so you don't put reactions. I may just don't put reactions. Or in the question, I may say, forget about reactions. Then you do not put CXC reactions here. Alright? What else am I missing?
I just had a quick question.
Yes.
So on the quiz, PA and pressure is not exposed atmosphere.
In
I'm
the
assuming since
quiz,
we-
no, it was because all of them are inside pipes.
Okay.
If you
so-
go back to the problem, you really do have, you see these are inside the pipe.
Okay, that's it.
But this one, you see that little thing is open. Right? So, here you don't have if it's open. So you don't have, and you have to read the question, double check, make sure that it's open, because sometimes they draw it the way that it's open, but they imagine there is a connecting pipe. So you read that, okay, that's open to atmosphere, PV 0. So you don't, let's go down. You do not put pressure forces here, right? And then at A, it's inside the pipe. You see this cut? That means you're cutting a pipe. Alright, so inside that pipe, PA. So if there is no reaction, that's it. That's a real load now. Inertial loads. Inertial load. There is one here, positive direction. V dot N is positive, times this is the actual thing is this way. Now if you put on the FPD, you just leave the sign. So you dash, 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 dash. The inertial load when you submit the quiz must be represented with the dash lines. Dash, 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 dash. If you don't put dash, you get confused. That's a real load. Right? In fact, when you come to vector statics, it doesn't matter if it's real or inertial, because you just sum them up with the same convention. You just sum them up. Similarly here, V dot N is negative, means this way, so you just flip the sign, the real one. But when you put in FED, dash, 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 going up. And it's N dot A here. Same here, V dot N is negative. And this way, velocity is this way, so the actual one is this way. When you put it on FED, dash, 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 goes down. So that's going to be your FED. Again, I may give you some numbers, and you just put it there. Another thing I may give is problem like that you have like a flow coming here, and it goes into that curvature, and bends like that. And I say find the force in X. Right? Again, FED, you see the FED he draws, he only includes the real loads, Fx, Fy. If I want to include the initial load, what do I have? Let's see right here. So that's my control volume, you see? It's around only this part of the fluid. Do you see that? So if I draw the control volume, well, of course, yes, there is a force coming from this object, the curvature on the fluid, which is actually a distributed load. You see it's everywhere. But you put the net result in one point. That's fine. But what are the distributed loads? Do I have pressure here? No. Why?
Because
It's in the atmosphere, it's exposed, it's not inside the pipe. So no pressure force here, no pressure force here, right? And nothing else, everywhere atmosphere. And then you will get confused, right? Everything is zero. Summation of force in that is zero. But look, he doesn't put the inertial load on the FDD. He just put it in the equation. So you write the equation and then say F external. But if you put inertial load, what do you have here? The velocity, you see? The velocity going this way.
The end would be
So,
going.
M dot V is negative times V negative. So the actual thing is this way. And you put it at FDD, is that M dot A dA. And then what about this point? The velocity is leaving. Now let's say this has an angle, right? Let's say this has an angle here. So you have an angle like that, and that angle is staying in the. So what you have put here? V dot, M dot E, VV. But is that the direction of the inertial load? You have to compute it. Velocity M dot V is this way, times V this way, so put opposite this way, so it's this way. V dot M negative, times that again positive, that's it. So these are inertial loads. Now, if you want to find Fx or dx, what do you do? Some forces, and x is zero. You no longer need the fluid equation. You just move vector settings. So dx negative plus m dot a dA plus m dot d dv is equal to zero. Something is wrong here. Can you tell me? Cosine 30. Cosine 30. Cosine. Because the x component of that and the b cosine 30.
Professor, now looking at it and thinking about it, the M dot, since that's rho VA, for B, would there be any area since it's going, would you use the area from before as, okay.
So why do you use the area from before now? Let's talk about that. Don't take anything as granted. If you write Bernoulli equation about this point, what do you get?
That the velocities are the
forget-
same.
Yeah, let's forget about the height, so the delta H is zero. Forget about the pressure because both of them are P0. So velocity here is equal to velocity. On the other hand, from the continuity equation, conservation of mass, what do we have for AB? You see? AB is constant. A1, B1 is equal to A2, B2, right? Conservation of mass, anywhere along this stream, right? So come here, what do you have here?
You have the area,
Area here times VA, so that value is constant, so that means if velocity is everywhere constant, what can I say about area?
the area is constant everywhere.
That's it. Do not take anything as granted, always say, only thing I have is continuity, momentum, and Bernoulli. Three equations so far. If you can't do it with that, just write it there and you get full credit. If you don't have enough equation for parameters. Right, just write every equation you have and work with that, solve it as much as you can, and you definitely get full credit. But if you forget one of these equations, then you realize, oh, I have too many unknowns. Well, because you're not using all your equations. All right, questions? Please, let's study. Monday is the midterm, right? Trainings need to put in Wednesday. You wanna study? You wanna study more? If not, moving to Wednesday. You wanna do that? How
No.
many people want to move to Wednesday?
No, we have a thermal exam.
Oh, you have a term exam. Oh, all right.
Don't,
I'm
can't go
sorry, I
back.
can't do that.
Yeah, we can't go back from
Term
that.
is maybe harder than this.
Friday.
Yeah.